So this is how we sell residential. We've got 90% plus of our clients are going to Passive House now. The one client right now that we're building a house for that didn't go Passive House would have gone Passive House, but personally, I didn't want the headache of trying to put a masonry fireplace in a Passive House. I know it can be done, I've seen it done, but I just didn't want the headache of it. And I just said, we'll just build you an energy efficient house. I'm not putting a fireplace in it. I'm not gonna try to do a Passive House with a fireplace, it's too much of a headache. But besides that, all the rest of them, we've been kind of doing this. So, Passive House, residential, delivered for cost parity and standard construction, okay? So if you're a typical American family, you've got a mortgage and an energy payment every month, right? That's a set amount you're going to pay roughly every month. So if we give our clients the choice that if that monthly cost is the same or less for a Passive House, would you rather put the money into the electric or the power company's pocket or into your pocket in form of equity, right? That's a no-brainer. When I tell people if you're going to spend $1,100 a month on power and mortgage, but more of the money is going to go into your equity than it's going to go into the power company's pocket, it makes sense, right? So that's easy to say, it's been easy to do, but it's really been really hard. It's taken us 3 years to get here. And I wanted to go a little bit into what we did and how we did it. Talk a little bit about this on the residential side before we get into the commercial. So I have been very lucky in that the people that work for me are very, very gifted, intelligent, and dedicated people. And we have, over the years, really honed and developed systems for about everything in our business, right? So everything from how a bill is paid to how we do callback to how we bill, everything's systematized. And this is not like, atoms imposing this on people. This is collaborative effort of the group. So what we kind of do is we develop a system. We come up with an idea. We implement it, we test it, we assess how that goes, we revise it, we implement it, we reassess it, we revise it again, we implement it again, we assess it again, on and on and on and on and on and on, until we make it so simple that you can't screw it up, right? We have what's called the Aaron Eanes rule. Aaron Eanes is one of the young, brilliant kids that work for me. He's been working for me a little over 10 years. He says, if it takes more than 2 people, it's too complicated. If you have to think about it, it's too complicated, right? I mean, the kid's brilliant. When I used to make systems, they were like, oh, this goes here, and there, and this, and there. So it's been great. So, so our system development, well, we studied a lot of systems. We actually found what I thought would be the perfect Passive House system. It was inexpensive, super easy to build, and it was really neat. It's called the Sobs building system. It's by this guy Nasser Saibi out in Phoenix, and my partner and I actually flew out to go meet him. He's a structural engineer. He's from Iran, and he takes EPS and he builds the house out of EPS, and then he sprays it with glass reinforced concrete. He's written a finite element analysis program to make sure that's what his thing is. And so he's got a completely thermal bridge free building, built super cheap, super easy. He's built a bunch of these in the States, maybe about 100 of them, and then he's built a bunch in other countries. And so we went down and we saw him and we talked it, but bottom line, we've done ICF, we've done SIPs. When I did SIPs the first time in 1984, I thought, wow, this is amazing stuff. This is going to take the building industry over. And what I learned was the building industry does not change very quickly, right? So even though the Saibi building system was brilliant for Passive House, I recognized that, you know what, I'm not going to be able to sell this. Because nobody's want to live in a foam house covered with concrete, not in Virginia. So if anybody wants to go do that, it's great. It's great stuff. But I figured that was not going to work. And the thing is, it was cheaper than what we're doing now. So we conceptualized the system. This was like an initial concept drawing of how are we going to do it. And the idea was we wanted to make it simple for people to do. We wanted to have as few objections as we can from all our subcontractors. So we just came up with a system where when a subcontractor walks into one of our buildings and they look at the interior and they're ready to do the rough in, it looks exactly like any other standard house they walk into, and it doesn't scare them, right? So the first thing we did, we started at the bottom, right here, with the foundation system, and I said, well, putting a building on foam, that's a little bit radical, right? And for us, we have to have termite. You guys have termites here? Yeah, so we termite treat everything. So we came up with this system, and the very first thing we did after we came up with the system was we commissioned a study, and we have a stamped report from a structural engineer that talks about the way this is all done, et cetera. So we've built now in 6 different localities in our area, and when we turn in our plans, we've used this detail on almost every project, except for Jesse's project, we use a slightly variance of that. We turn in this structural report that we got from our engineer. I've never had a question. They're totally happy with it. Now, what we did was we implemented and tested. This was one of our first projects. Now, I want to point something out here. I call this the Duclos method. Thanks to Mike Duclos, Paul Panish. They kind of were the ones who. And so I've been teaching builder trainings, and I teach people the Duclos method of airtightness, right? So what we did was when we started with our airtightness, first thing we do is we sheathe the entire building except for a door, and we get a baseline test. So we know what our leakage is on the envelope with no penetrations. And we have actually a little chart that we go by the cubic footage of the building as to what that should be, right? And it goes down as the building gets bigger. And then we pop our holes in and we test again. So we pop our windows in, then we test again, and we know if there's any leaks, they're in the windows. And we go fix all those. And then we do our rough ends, which I don't actually have a picture of, and we test again. And so then we know any penetrations are now down to the mechanical. And what we've been able to do is consistently achieve ACHs that are between 0.2 and 0.4 on our buildings using this method, to the point where now my guys are saying, do we really need to do this? And I say, yes, we really need to do this. We need to do this for a while longer. So, like here's an example of testing and assessing. Here's Rob. This is one of my super best friends and works with me. But this was our first prototype form. Well, what we learned with our prototype form was that, you know, we actually ran this little piece of foam all the way up to the top of the slab. And what we learned was when we put our vapor barrier and we poured our concrete, we couldn't get a nice screed on it, right? Because of the way the plastic was, right? So when we got to the next one, we cut 1.5 inches off that. You know, we reduced it by 1.5 inches. We used the plates that we would eventually use for sill plates. We wrapped our plastic over. We put the plate on top with long screws screwed in it. With the 3-pound foam, it's pretty stout. And then we were able to use that top plate, or you know, that plate, as a screed board, so we get a nice smooth finish. So when we go put our walls, we weren't dealing with ripples, you know, and up and downs. So, you know, just that was a tiny little improvement, but that was that iterative process of learning how to do it. So what we do is we assess. We're constantly assessing you know, these details. How are we doing them? What are we doing what can we do to make it simpler? How do we put in, you know, the belt and suspenders kind of methodology of airtightness? One of the things that really concerns me about these buildings we're building is long-term durability. We're building these buildings to last 100, 200 years, right? We want them to last a really long time. And the thing that really concerns me is a lot of the secret sauce of Passive House is airtight. And how airtight are these buildings going to be in the long term, right? So, you know, relying on tapes, relying on sealants makes me a little bit nervous. So we've been actually using like a zip wall panel and our tapes, but then we've come and we put an adhesive on the entire zip wall panel and adhere EPS to it to kind of make sure that tape's not going anywhere over 50 years. Whether or not it is, I don't know. I mean, I'm just doing my best I can. So then, once we get the baseline of the system, what we do is we start adding to the system. So we take our system and then we develop it for a slab, we test it, and then we say, okay, well, what if we put it on the basement? Well, that basement's expensive to build, so what if we put it on what's called an ideal wall, which is a precast basement system, which we've been working with these guys to develop a thermal bridge-free system when they've been great to work with. And then, you know, we of course have to come up with all these details of how all this works to airtight it and to get rid of thermal bridging. And the interesting part, see that little detail? I mean, this detail right here we've now implemented in the field, and Rob has already got a new detail here that works better. See, it's constant improvement and simplification of what we're doing. You know, how do we put in windows? How is that all done? And how are we, I mean, every time we do something, we're trying to figure out, can we do it? You know, what we do, we don't just go and do it, we do it, and then we think about, well, did we do it the best we could? I can't tell you how many times we're there in the evening, 4 or 5 of me and my guys that work with me, sitting around going, what can we do better? What can we do quicker? What can we do simpler? And we come up with these great ideas, you know? I mean, we've got a house that we're getting ready to build that's got, you know, I designed it, so it's got curves, and it's got big curved kind of bow windows in it. And originally it was designed as a non-passive house, and it's been switched to a passive house. So now we're trying to figure out, you know, what's the best way to build these curved windows and be able to maintain the airtightness, maintain the thermal breaks, and still keep the aesthetic. And we sat for 2 hours just this week talking about it, and Rob came up with a really great idea to build these plywood forms in the shop and then hang it's a non-structural canvas. But anyway, we're constantly doing this. It's not like it never stops, right? So it's really cool. And then, you know, then you re-implement, retest, reassess, right? Here's another project here, and here's the Duclos method again. Works totally perfect, Mike. Thank you very much. But there's our blower door right there. But you know, this stuff works. Simple, simple, simple. And then the other thing is, after we've assessed, after we've tested and reassessed and verified, then we systematize, right? And we start, I don't want to do that. All right, and then we start making checklists. We love checklists in my company. We have all kinds of checklists, simple checklists. But this starts telling my guys, when we're starting to do passive house projects, what are the things they want to look after? Where do they get their stuff? What are they trying to get? You know, right now we're doing, you know, Energy Star, HERS rating, PS Plus. We're doing all that certification, and you know, we have you know, all what they have to do. And then there, Mike, the Duclos method testing. Look at that. See, these are our targets. Target benchmark after slab wall, ceiling, prior to windows and doors. Those are the ACH50s that we're shooting for at those cubic footages, right? And then second test after windows, third test after MEP, right? So those are the targets that the guys are shooting for, right? So you know, it's about simplification, systemization. That's where we go with it. So that was an example of the residential. And the way we sell the residential is by saying it costs no difference, so why wouldn't you? And the way we make that happen is through very rigorous systemization, testing, reassessment, retesting, and just working as a team to make sure that we have the simplest, easiest, simplest system to get it done. So why does commercial construction make sense? Well, it makes dollars and cents. The first thing, when you're looking at the cost of a project that's a very large project, the cost impact to upgrade the envelope, because it's such a smaller percentage of the entire project, becomes much, much, much less in terms of percentage of the overall project. The other thing is that in commercial construction, a lot of the things that we do standard in commercial construction are things that should be part of passive house anyway. So for the last 4 or 5 years, every commercial project we've done, and that's about 75% of our work, we're putting on liquid applied air barriers, right? And that's pretty much standard in commercial construction now. I mean, it's pretty, you know, you see them, but you know what? My point to my subcontractors is, okay, I'm already paying you $1.50 a square foot to put this stuff on. I'm not gonna pay you any more to put it on right, right? So it should cost no more for me to get a correctly applied liquid air barrier than what they do with their, okay, send Juan up there with a roller and, you know, have it half-assed done, right? So part of this is knowing that when you're looking at the cost is that we're already doing a lot of this stuff, we're doing it wrong. And why would you pay more money to do something right? You're just paying more money to do it wrong. So there should be no cost delta there.